everyone, this is Alan. Today I want to talk about how to evaluate air movement. I want to start with two pictures. This is the first one. Chicago is known as a windy city, and do you wonder why Chicago is so windy? This is an interesting picture, but addresses interesting problems. Second one, do you sometimes feel uncomfortable in the room, like in the office, because like the air diffuser is blowing too much air? Sometimes you feel like I need more fresh air because of the diffusers. It happens in our conference room. And why understanding air movement is so important? Generally, it's a big part of indoor environmental quality. So comfortable environment and prudence is what mechanical engineers care. We don't care about structural or aerodynamic stuff. And I want to talk a little bit more about hospitals, like patient's room and operation rooms, which understanding air movement is very important for, like, you have to understand how the particles move with air. So some hospitals can do this kind of service. But the question is, how are we going to do this? How are we going to evaluate the air movement? Air cannot be seen. Are we going to calculate these equations from college manually? We want to visualize the result. How can we do that? So I want to introduce a new method. It's not a new method, but it's a method called computational fluid dynamics. The computer is going to take all these equations, and the computer is going to calculate these equations for you. And the problem is going to be solved, and it presents you the result pretty well. So in the next slides, yep, that's how this method presents results. As you can see, no matter it's inside or outside. For example, inside, and the other is like outside. So with this method, you can understand why Chicago is so windy. And I want to walk you through, guys, through a project I did in the past. It's a wind simulation Purdue football stadium project. Purdue spent some money on this. They did the renovation for the stadium, and we worked with them to help them solve the problem. So first, let's take a look at how wind speed affects football games. Generally, according to a study was conducted. So generally, when the wind speed speeds up, you have to run more, but you pass less. That's how it affects. This is how the stadium looks like. It's a huge stadium, located in West Lafayette, Indiana, and it has near 60,000 capacity. It has a huge opening on the southeast side, and it's facing northeast. It's huge. So the objective of this project is to simulate the wind flow pattern around and inside the stadium to help the design team understand the wind flow pattern, like change, how the wind flow pattern change because of the shape. They change the shape. So here's the design. The design team expect some problems because of the shape. As you can see, from the southeast side, there is a valley shape. They kind of worry about the wind going to be accelerated through that shape and stay in the stadium, so which is not good. So basically the method is pretty straightforward. First, you have to build the 3D model, and then you have to import the model to the safety software, and you have to set parameters, and then run the simulation, and then you can get the result. And based on the result, you can propose solutions. Here's how the model looks like in AUTOCAD. It's basically, I would say, strictly follow the design concept, like the dimensions, surrounding buildings, even the topography. So it's all in this 3D model. AUTOCAD is a great software to have this model. Here is the simulation result. We found, compared to current stadium and design concept and the solution, we find some problems like vortexes and high velocities in the design concept, which is not good for a stadium, and they don't like it. So we have to analyze the result and find why is this happening. As you can see, there are several cases. First, the valley shape accelerates the wind and the wing stays in the stadium, and the southeast side block the wind. So we propose a solution which moving the southeast side extension upwards by 24 feet. So it's going to be there's going to be a tunnel under that southeast side extension. It will serve as players' entrance tunnel. The design team is happy about that. So let's review the whole process from the design concept to our 3D model and to the safety software, and then run the simulation. We can get the result. Based on the result, we can analyze the result and propose solutions to the design team. There are pros and cons for this kind of method. Pros, low cost compared to experiments, less time. And the best part is visualization. You can directly see how this air moves, like the velocity, the direction. But it has accuracy limitation, and it's fairly expensive compared to other services. So I want to introduce this method to design more healthier buildings, like not only for hospitals, like for healthcare, but also for other buildings like mixed-use offices, theaters, like that. Thank you, guys.